All right, welcome everybody. Thank you guys so much for joining us today. So today we're talking about Tales from the Forum. Whoa, scary things you guys ask us on Facebook, which is actually kind of fun. So let's get to it. So that's my ugly mug there. So hi guys, my name's Jorge Segura. I'm often mistaken for a bot online because I'm asking or answering questions on Facebook at all hours of the day, mostly because I'm a super nerd. If you're looking for me online, my social media handle is SQL Chicken. Don't ask. I work for Microsoft as a developer consultant. So, yes, I do have a day job outside of answering stuff on Facebook. So, yes, I do this on a daily. Power BI is my passion, which comes to the next point. I love Power BI to an almost unhealthy degree. And I really, really wanted to name my son Dax, but I lost the bet on that one. So. And then everything that I'm going to be showing you guys here, you guys can actually download all these files, all these example codes. Normally when I answer questions on Facebook, 99.9% of the time I'm on mobile, so I don't have desktop open in front of me, but if there's a interesting enough problem or issue, I'll actually, when I get back to my desktop, like create a sample file and post it up on GitHub and include it with my response. And that's kind of where this presentation was born from. So you can go to GitHub, go download the sample files, look at the code, make fun of me, whatever, but it's all there for the taking. All right, so that being said, get on with it. Let's go to the good stuff. All right, so we're going to cover a couple different things today. Now, lesson number one actually has nothing to do with Power BI Desktop whatsoever. So we are going to talk a little bit about, since this is Tales from the Forum, we're going to talk a little bit about how you can actually help yourself more when you are in a situation where you're asking kind of strangers on the internet for help. So number one tip, search engines are the world's greatest consultant. Google, Bing, Dogpile, whatever you want to use. Search engines are prevalent, they're free, they are so easy, and the answers are right there for the taking. In fact, 9 times out of 10, if you look at the way somebody crafts a question on a forum posting, you could have just as easily copied and pasted that into a search engine and gotten results immediately instead of waiting for however much time it takes for somebody to actually read your forum posting and then respond to it. Forums are kind of funny. Sometimes you'll post something and it'll be either minutes or hours or days before somebody gets back to you. Search engines are online 24/7 and the answers to all the world's questions are right there. Now, those are the big search engines that crawl the entire web for all sorts of stuff. But when you join a forum, forums typically also have built-in search engines as well. And more than likely, somebody else probably has already asked the same question as you at some point in time. Now, I'm going to flip over here to Facebook, and oops, well, wrong one. Over here. Here we go. So I'm already here on the Power BI Global User Group. Now, here is the Facebook user group. Again, obviously, this presentation was born out of the Global Power BI User Group. If you're not a member of this group, come join us. It's fun. Now, in this group, there is this lovely little search this group. So if you join this group and you're looking for something specific, there is actually a built-in search. If you use the mobile app like I do on the majority of the time, there's also search at the top. So when you actually navigate into a Facebook group, if you look, there's actually contextual search that searches within the group, within the mobile app as well. All right, so make sure you guys utilize that because it's easy, it's built in, and then in the context of the actual Facebook global group here, we actually have rules right up front that state, guys, please try to do a search on your own. All right, which kind of dovetails here into lesson number 2, asking for help. So there are proper ways to ask for help on the internet from strangers. All right. So number 1, abide by the group or community rules. So our Facebook group specifically One of the primary rules that when you go join it for the first time, there's 3 rules that you have to answer the questions to, kind of like a troll under the bridge. You got to answer the riddles. But the very first thing is, hey, do you abide by the rules, which include doing a basic search for basic questions? If you answer yes to that, the second one is, all right, just as a proof that you understand number 1, go do a basic search for this question that I'm about to ask you. Last one is, do you abide by the rules, which again, we have a rule sheet up there. Now, every community has its own set of specific rules. And if you join a new online community, always please review those rules first, because every community kind of polices itself differently and has different expectations. But that's what the rules are set for, just to kind of level set the playing field and put everybody on the same page. Number 2, make an effort yourself first. And this is another big key one. You'll notice that my personal response is, a lot of the times I seem kind of short with people sometimes when I respond with, what did you try first? I won't even answer the person's question. The first thing I ask is, what did you try first? Because the way that you ask a question is really going to depend on how you get response. So if somebody says, what is the calculation for this? I'm going to ask you, what did you try first? So 1, I can see whether or not you made an effort yourself first. 2, if you tried something already, that's going to affect the way I respond. It said, hey, I tried using the filter function, but I didn't work. Actually, the next slide here is kind of an example of this. So here's an example of kind of a quote unquote bad question. How do I calculate totals for only color red? Now, the question itself is not bad. It's not like, oh, I'm so angry this person asked that. But there's no context here. I have no idea what this person tried. I have no idea what their model looks like, etc. But if you ask something like this, hey guys, how do I calculate for total red? I have a table that looks like this. Here's some sample data set of what their data looks like. And then I tried using this formula, but the total keeps repeating and I don't understand why, right? Very clear. The person asked their question. They established that they tried something themselves. They gave the people that are going to be answering their question context, right? Here's a sample data set. Here's what I'm trying to accomplish. And then also, I tried something, but I don't fully understand it. Now, if somebody does this, yes, there are plenty of articles on the internet on filtering, but here I can tell that this person at least made an effort and they were going in the right direction. They just need a little bit more guidance. Now, personally, for me, when I answer questions online, I'm more of the mindset of I prefer to teach you to fish rather than just give you the answer. So if I respond to this, you could just go here, calculate equals blah blah blah, and leave it at that. But one, I like having a dialogue, a back and forth to actually teach people, because if you just give somebody the answer and then run away, they really didn't learn anything. All they did was copy and paste code and then went back to work, which doesn't help them in the long run, right? So that was point number 3, provide all the relevant information up front. Number 4, urgency is relative. Guys, I see this all the time. Somebody goes on a forum, goes in all caps, I need this right away. My boss says I need this. That's great, but I don't work for your boss, and your stress level is not really my responsibility. So don't go shouting at people, especially strangers that you don't know, I need this answer right away. Because, and I don't mean to make this so kind of abrupt, we don't owe you anything, all right? I don't owe you a response right away. The rest of us have lives, have jobs, are doing other things. People answer questions on forums not as a day job, although some forums may have some full-time staff people, but 99% of forums that you are that you're in are probably made up of people just like you that are out there on their own time. So just be very cognizant of the way in which you present yourself. And then this leads to the last point here. The quality of the question or the message dictates the quality of the response. On the internet, and language alert here. There is a lovely little rule called Wheaton's Law, and this comes from Will Wheaton of Star Trek fame. He has a little law that says, don't be a dick, right? I love this one. It's very simple, very to the point. Basically, don't be rude to other people for no reason. And I see this a lot. People will be kind of curt or just straight up rude or just bite your head off on a response. Golden rule, be nice to other people. They'll be nice to you. Just everybody be kind. It's the internet. We all got to live here. All right. Now let's get to the fun stuff. So let's get into the actual technical stuff. So number one, filtering. All right. We all do this all the time. So let's get into some examples here. So the filtering, let's get out of slide deck mode here, and we're going to go to our friends. Whoops, let's minimize this guy. Nobody cares about GitHub right now. Let's go to the filtering example. All right, so hopefully you guys can see this. I'll try to put some more screen real estate and I'll zoom in where I can. All right, so here we've got a lovely little data set. And yes, I am a giant nerd, so if you see comic book names, start geeking out. Yeah, I'm a nerd. All right, so we've got a data set here for a bunch of people, a bunch of dates, and then when their values were recorded. So I got, these are the raw values here. And I got a calculation that maybe I want to calculate 2019 values only. Now we've got two columns here side by side that are showing two slightly different outputs here. So these are calculated measures, so I want to show you guys kind of the side by side to show you how the filter function kind of works in the DAX language. By the way, if you are not familiar with the DAX language, there's a couple great places to go kind of learn it. The guided learning on the Power BI site is a great place to go to. The guided learning is linked at the top of the Facebook user group description. Here's another PBI guided learning. All right, that is a shortcut link to it if you ever forget it. You can also get to guided learning directly from Power BI Desktop. If you have Power BI Desktop open and go to the Help tab, there is a big shiny button there for guided learning. In the guided learning tutorials, there is a dedicated DAX tutorial that I highly recommend to kind of learn the basics here. All right, so here what we're looking at is two measures. You can see that the results are the same, but when you break it down like this contextually, you get very different behaviors. Here we're seeing this number repeated over and over here, whereas here it's kind of a broken down number. So what's the difference here? So the 2019 values, both of these calculations kind of start the same way. Calculate, we're going to sum up the value column, and then the calculate function, the second half of a calculate function is a filter criteria. So if I don't use the keyword filter, if I just go, here I'm saying I only want to look at the year of 2019, right? What you'll notice here is when I place this on a pivot and you get the results here, I get this number repeated over and over again. And you're like, what's going on? Whereas over here on the 2019 filtered, we're going to start the same way, calculate sum, but here on the second half, I'm going to actually use the keyword filter. Now, the filter keyword, the first input that it wants is actually a table reference. I prefer, rather than filtering out an entire table, for performance reasons, I will filter on a particular column, and that's where I'm using this values approach here. So rather than filtering out the entire table, what I'm going to do is I'm going to kind of create a temp table of sorts of all the values from the date. So I'm basically using this column and kind of using it as a table reference. So I'm only having to filter through the values in this one column. And from here, I'm saying I want the year 2019. So I'm going to calculate the 2019 stuff here. Now, with both of these, it is calculating only 2019. You'll notice that you get blanks here for any non-2019 values, 2018, Now this one's a little bit weird. For some reason it's calculating December 1st, 2018 is 19, so I'll have to go back and take a look at that. But you get the blanks here for the for anything that is not 2019. Now where it breaks down here is that this guy is kind of a running total, whereas this guy is doing a repeat. That's because without the filter function, what this is doing is it's doing a different context. It's not doing row context. It's looking at the data set as a whole. So it's calculating all of 2019 for Charles Xavier. All of Charles's 2019 values came out to 4597. So it repeats that value over and over again for Charles. And then Max, he had a 2018 here, but you don't see a row for that because you get the 2019 values, repeat, 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 and then Scott just has the one in 2019, so you get 1,000. Now both of them, again, the totals are the same, because the other little tricky part about DAX is that the total row is calculated independently of everything else. This here is not summing up everything up here. That's why sometimes you'll see weird stuff like this. Here's 9,000. If I were to add up all these numbers here, it adds manually, it adds up to way more than 9,000, whereas a total row is showing us a different number there. Again, that's because the totals row is calculated independently of this entire thing, so this calculation context is happening without any additional row context. All right. So that's kind of a basic rundown here of the filter. Now I have another filter example here for somebody came on to the forum and it was asking, hey, I want to do calculations for only Mondays. So kind of how do I do that? So my data set here, I've got all these dates, values. Actually, let's take a look at the raw data set here. So my data set looks like this. I've got a whole list of dates here, a value, and then I've got a couple of calculated columns that I've created here. So the day of week, simply I'm using weekday. Let's do a live zoom here. I'm using weekday of the transaction date. So that's going to return me a numeric representation of that day. So this is a Monday, so Monday returns 2. This calculated column here is returning the actual name of the day, and I use the format function in this case to return that day label. Now the reason I included this here is so I can use it as a slicer, because I want to be able to slice by the day of the week here. So if I come back here to my report visual, I got my slicer here that's using the day column. So I got all my days lined up nicely. And over here, the raw data. Now, I've got this Mondays only calculation. So let's take a look at the measure there. So it's Mondays only. All right, so here we're doing calculate sum, and then here again, transaction day of week equals 2. So that was that column that I did, calculate only Mondays. And you can see here, when I put this on the pivot, you get the blanks here because anything that's not Monday is not calculated. And then we go through and it calculates that Monday. All right. Now I've got all Mondays. So I think the other half of the question for the person that was asking is, yeah, if I were to like click on this row, it gives me the value for that Monday, but I want all the Mondays up to a certain date. So the second half of this puzzle was the all Mondays together. And here we did calculate. Now the other beautiful thing about DAX is a measure can reference another measure. This is great for code reuse and kind of tying things together. So here I'm calculate. I'm using the Mondays only measure that I already created. But this time what I'm doing in my filter criteria for the calculate, I'm doing all. So all removes any external filter context that are applied here. So I'm going to ignore any external filter context and I'm going to calculate, over all the transaction dates. So this is kind of almost, think of it like a running total of all the Mondays for the year. So if I were to kind of click here, I'm going to control click a couple of Monday values here. So in a second here, I clicked off 3 dates, January 1st, 8th, and 9th. The 9th is a Tuesday. However, you can see the calculation for the all Mondays. It should add these guys together. So all Mondays. Oh, you know what? Probably the filter keyword. So whoops. But you get the gist there. The all Mondays is going to look at all the, oh, actually, no, we get the 145 because, again, it's ignoring all the filter context. So that's all my Mondays combined in my entire data set, because even though I've selected these guys as a filter, the Mondays only calculation is correct. The Mondays only is tacking these two together, but all my Mondays together is 145,000. And again, that's what the keyword all is doing, ignores that and calculates it. So that was specifically asked by one of the forum members once. All right, so let's get back here. Let's take a look at the next one. All right, loading tables that needed. Okay, so this one, India states. So another problem that I see often with users is that they will pull in all these tables from all these sources, and they might pull in a table just as kind of an interim calculation, or we're just borrowing a column from this, and then they leave it in their model, right? The problem with this is you end up with a model with like 50 different tables, and if you look at your file size of your PBIX file at the end, it's quite bloated. It's quite huge, and ultimately, like, you're only using 1 or 2 of those tables in your visuals. So that's a giant waste. So in this example, I've got this one table here called India Top Cities. All right, now one table in my model, very simple. But if I go into Power Query, let's take a look at what actually made up that one table. And in this case, it's actually quite a few. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 different tables. Actually, technically 10. But all these tables here, what's interesting about them is these are just web scrapes off Wikipedia. So all of these tables, what I did was I did a search, yeah, you see how important that is? I did a search for all the populations of the top cities in India, and Wikipedia has that information, but it's chunked out across tables. They only do it in like groups of 25, so 1 to 25, 100 to 125, et cetera, et cetera. So I was only kind of able to get the this stuff at kind of a subset, and it looks like they broke it on me. Thank you, Wikipedia. But here's an example of what the data look like. So top 25 cities here in India. Now, I don't want to have 1, 2, 3, blah, 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 that many tables in my column. So what I want to do is I want to bring them all together. So I can union them all together into a single table, because all 10 of these tables basically have the same structure. So you can use the append queries transform to basically mash them together. It's very similar to a union on SQL to get a single table together. Now, the other half of this particular user's question came to, they didn't have the state, the India state in their data set, or they only had it in one table, but they needed to apply it to the rest. Again, you can download the PBIX file, and I walk through and I document here all the different steps that I took. Looks like it broke. Maybe Wikipedia changed something since I originally made this. But here in this PBIX file, basically I walk through exactly how I put this together. Now, the secret sauce here is that I disabled the loads on the tables that I didn't need. If I come back here to Power Query, Even though I brought these in Power Query, what you do is you right click the table and you'll notice that enable load is unchecked. What this means is that Power Query is going to pull that data from wherever the source is. It's going to use it in the transformation purposes, but I do not need to store top Indian cities 1 to 25 in my final data model. The only one that really gets stored is, I believe, this India top cities, which is my final table with all the merged tables together. So I end up with one table. And here, this was another one I didn't load. I believe what I was doing here was just pulling the states by themselves and then unioning it or merging it into the top cities. So that way I got all these states tacked into the final data set. So the final table looks like this. The rank from Wikipedia, the city name, the population, and then the state or union territory. And because I have the state or union territory, I get this nice little slicer. So if I look at Delhi, let's see how that. So within Delhi, I've got these cities, these populations, and because I wanted to get fancy with it, I got a little map here. So it's showing us the population sizes by bubbles on a nice little map. All right. So fun ways to kind of dress up your visuals there. There we go. All right, so that's another fun little filtering example there. Close some of this up to give myself some resources. All right, I'll just use this. All right, pivot. I love me some pivot. A lot of times this one will solve what seems to be kind of a painful problem. So pivots, how that work? So let's go take a look at my pivot unpivot example. All right, so in this case, and again, all these examples, thankfully the person asking the question gave a sample data set, so a lot of the times I'm able to work off that for these examples. So in this case, the person goes, all right, I have these codes, and then the way that my data is coming in is I got a column for each year. But the problem, if I use that original data table like that, you could see that I have to like manually throw the year into the visual since they're individual columns. You know, when the 2019 data comes in, I don't want to have to open up the PBIX file and manually add the 2019 field in here. So how can I get around that? So the answer is we pivot. So let's go to Power Query here. Sorry, I'm a pop culture nerd. I love Friends. All right, so here's the original data set. Again, 2018, 2017 fields here. So let's take a look here. So this is what it originally looked like, and this is what we wind up with. Now, in this scenario, what we do is unpivot. And again, if we look here at unpivot, basically what we did is I selected the columns and then unpivoted. And you can tell what I did here. I have the formula bar showing here when I do my Power Query work because I actually want to see what transformations were done. So you can actually kind of look at what I did. So the unpivot was based on the code field. So just to actually see this in action, I can quickly duplicate this guy here so we can actually do it together on the line. So with this column selected, I simply come up here to transform, and I can do unpivot columns, bing, bang, boom, and you get that. Now, here's the funny thing, and here's my dirty little secret. Guys, I can never remember whether or not I need to pivot, unpivot, or what. I don't know why. My brain just does not hold that information. Now, this is why I love Power Query, because I just unpivoted and I'm like, wait, that's not what I wanted at all. So when I do something, I can simply just do it, mess up, and go back a step. All right, so that's not what I wanted. So let me try unpivot other columns. There we go. That's what I wanted. So I unpivoted the other columns from code, and when you do that, it turns the attribute value pair here. So now this is closer to what I want. I got the attribute here, the year, and then the value, and then the different codes. So that's what happened here. I got this guy. Now from here, I unpivoted, and then from there, I pivot. Wow, that's weird. Why would we do that? So that way we can turn these guys into rows, and then the codes can be dynamic columns. So now I pivot, and if you look at the code, we unpivoted other columns. So if I come here, let's say we pivot, pivot. Now, when you pivot, it asks you what your values column is going to be. You do that. Here on the advanced functions, you can pick an aggregate, or you can say don't aggregate. So I don't want an aggregation to occur. I just want it to unpivot or pivot the raw values. So now you can see what it did there. It turned the 2017-18 into the rows, and then I get ABC as the column header. So now as new data comes in, if 2019 comes in, these transformations occur automatically. So the 2019 will undergo everything, and then I should get a new row of 2019 in there. All right. And there you go. So now you've got this in rows. So if I go back to my visuals, I do not want to change my stuff here. So I get my new table. I get my new table like this. So when I go to create my visuals, I can just throw the year as the axis, and it'll be dynamic, and I get my values displayed. All right. Love me some pivoting and unpivoting. All right, so next up on the block, let's mix some of these together. So let's combine them. We got 37 minutes here, so we got some time. All right, so little mixing and matching of kind of everything that we've seen so far. So I got another one here called Tales from the Forum. Now this guy here was a fun one. So the other thing that I do is sometimes I'll include a screenshot of the original question asked on the forum, just to give kind of context here. So here's the question. The person was saying, hey, I'm monitoring CPUs. This is what my data looks like. Again, God bless this guy for giving me a screenshot of the sample data set, so we know how to answer this question. And he was very specific. He's like, yeah, you know, what I'm trying to find is basically I'm collecting data every X amount of seconds. I want to know the duration of a spike between time. All right. So this was kind of fun. And again, if you look at the code file, I walked through the solution here. Here's what I did to transform the data. Here's what I did for the calculations. Here's what I did for the visual. All right. So again, let's go into Power Query here. Let's take a look at the original data set and what we did for it. So this was the sample. Oh, yeah. This one's going to be broken because I just redid my computer and the Excel file can't be found right now. All right, so basically what happens here is we took that and unpivoted it. You can see that here, and I will upload the Excel file into GitHub so this doesn't break on you when you look at it. And then the secret sauce here is that I added a custom column, and I used Power Query to derive this. If I open this up, hopefully the UI will let me. Nope, because I can't get to it right now. All right, so when you add a custom column here through Power Query, you can use the M language to basically derive a new value. So what I did here was I added a hour column, because what I wanted to do, I looked at this and I go, all right, if I look at the entire data set at the very granular level, it's going to be overwhelming. I want to be able to analyze the CPU by hour blocks. So I added an hour block, basically using the time.hour function in Power Query. So that gave me the 24-hour numeric for the hour representation. So I wind up here in the final data set looking like this. So I got the server ID, the system time that it was collected, the attribute value here. Again, this was due to the unpivoting. The attributes, a CPU that was collected, the value at that time, and then here's the hour block. So this occurred 1 is 1 a.m. You can see that here from the raw system time. And again, the reason I did something like this is because I want to be able to do something like this. Come over and create a nice slicer that allows us to explore the data that way. Now, what I did here in calculations, you can see I've got the average of all CPUs, the average for each individual CPU. And these are very straightforward measures. So I broke this out granularly, and when I create measures, I try to explicitly break this out because, again, I want my code to be very modular. I want to be able to plug and play. I don't want to have to rewrite sum of value 50 times, right? If I do it once, then I can reference that in another calculation later on. So average is CPU1, calculating the average of the value column, and here we're using the filter keyword explicitly for CPU1, rinse and repeat for 2 and 3. Now, here the average of all CPUs is simply all of them together, all right? Now, this gives us these little calculations, and then we have a duration calculation. So let's take a look at this one. So this is calculating the duration between two collection points. Now here, this is where I use the magic of DAX variables. So what I want to do is I want to find what the least point is. So we're going to do min of the system time selected, and then high time is max, right? So now we've stored those two values independently as variables. And this is very straightforward. I use the date diff to get the date diff, the difference between these guys in seconds, right? Because if you look at the original query ask was, hey, I want to get the average of these CPUs, and then I want to figure out, like, if it goes above the average, how long that was above average. So if we come into this chart now, I'm going to do a live zoom here. If I select a single data point here, watch what happens. I select a single data point here. If I mouse over it, you can see this happened at 7:26:54, right? And take a look at this. CPU 2. Now CPU 2 is selected because, again, if I control click these points, each one of these is on a different line. It's going to take a second here because I didn't have all three selected. That's why I'm not getting the calculations here. But the other thing to notice is that duration is 0. Now, if I want to calculate the difference between this spike and this spike, I simply hold down the control key and left click. It's going to take a second here. Now, the difference between these selected points is 180 seconds. So within that 180 seconds, the average CPU for that CPU, which was 2, was 89. All right, kind of neat. So this is very dynamic. And if I come here and, again, control click other data points here, I'm going to pick from what's CPU 1 there, or nope, that was CPU 3, and then CPU 3 at the same time slot was this spike right here. So again, as I'm pressing these, you can see that the numbers, again, it's a 180 duration, but you get the dynamic averages calculated for you automatically. So you can do some pretty cool stuff here. Now here's another one, no calculation totals. This guy was saying, hey, here's my data set. Unfortunately, tables or matrices calculate totals automatically, but I don't need this total down here. How can I avoid that? Long story short, here's the raw one. Here's the calculated measures with no total. And here, what we're doing is calculate sum, and then here's our fancy filter again. Again, filtering over all the values, which is the attributes. And then the second half is has one value equals true. Remember earlier how I said in DAX, the total field is calculated independently of everything else. Without this, it would have put a total here. But since I said has one value equals true, this total row, it's going to go evaluate this calculation, and because there is no attribute for this row, it does not calculate a total. So that's how I get away with calculating all this stuff correctly without having to include a total. All right. Deriving dates, this was another fun one. So we got this one and one more after this, guys. So deriving dates was kind of an interesting challenge. This person wanted to figure out, they were working with like hotel type dates. And the original, again, here's the screenshot. This person stated their problem, included a sample data set. Love this. And again, here's an example of what have you tried? And me asking, is this the only table in the data set, or is it just one giant flat table? All right. So here is an example of what the original data set looks like. So we got the guests. Oh, actually, spoiler alert. I got the guest stay dates there. If I take that off, this was what the original data set looked like. Cersei, John, and Tyrion were all staying at the hotels at various different dates. Now, what we want to do is we want to calculate the number of nights they stayed, but here's the rub. If I stayed in December here, one night or 2 nights, and then I stayed in January 2 nights, I should get 2 for January, 2 for December. If you just try to do the count, or date diff between it, it's just going to give you 4 or 3 or whatever that is, but it doesn't break it down by month because of, potentially, in this case, I have a date dimension. The date dimension is connected. It's got an active relationship based on stay dates. So any counts are going to be based on that active relationship, and the stay dates here is going to, or actually, I did that after I fixed this up, but the count calculation is going to be based on the active relationship. Now here is the final result here. Up in the top. So you can see John in January of 2019 stayed 3. Now this is the number of days stayed. Nights is simply number of days minus 1. Now this was useful, or this type of calculation is useful for, in this case, like if you're in the hotel industry and you're trying to figure out like a reward tier for somebody. If you've stayed 50 nights with us in the past 60 days, then you are, platinum tier or something like that. So they not only need to know how many total days you stayed, but days by month, because again, if I stay in December and it goes over to January, you might not have been eligible on that stay. Again, everybody has their own different rules, but you get the gist here. All right, and then here you can see for Cersei, her stay actually went over 2 days. So here we got the 2 and 2 that I mentioned there. So it was a total of 4 days, but 2 and 2 for the nights. All right, so how did we do this? Let's go into ULD Power Query. So again, this is what it looked like originally. Again, 3 rows of data, ID guest, the names, and the arrival and departure dates. Now, the kind of key here is that we have the arrival and departure dates, but we don't have the data of the days between. All right, so that's what we're going to do some magic here. Now, I added this custom column here. So this gives me the number of room nights, and I probably could have done this later on, but again, an example of how you can do calculations in Power Query rather than waiting for calculated columns in DAX. Duration.days, the duration, departure minus arrival, gives me 9, 2, and 3 there. All right, now this here is the meat of it. Now, the fun part about this one, and you may not be aware of it, if you right-click a step in Power Query and go to Properties, you can put some documentation in your stuff. So if you guys go download this sample column later, go look at the description field. I put a description of what I did, and also I derived this technique from a blog post I found via surprise, surprise, a search engine. So I went out and found this technique, and I just applied it here. So what happened here, let's take a look at the gear icon here. So this was kind of a neat trick. So there's this number.from function that's built into Power Query. So it's going to basically dynamically, number.from gives me the numeric representation of the date, and then I put the dot dot there, and that's basically like a dynamic array, and say give me the numbers from this to this, and then derive all the numbers in between those points. So when you're done doing that function, what you end up is this guy, and you can look and you get this column here, stay dates, and well, that's not a date. What's going on with that? Well, what's neat is all you have to do is simply right click and do change type into a date, and Power BI or Power Query in this case knows what it is, and boom, look at that. You change that numeric to a date, 10/25, 26, 27, 28. So you can see that my function worked properly. That is the, now I got a row of data for every day that person stayed. And again, this is why maybe I should have held off on the room nights, but you know, I'm dumb sometimes. All right, and then finally, I'm going to insert a merged column here. This was just me. I have the first name and last name, so I just put guest name and tacked it together. Nothing really special there. But the meat of this problem is that function call there. And again, that gets you this. And then here, the number of nights stayed. First, we have to look at number of days stayed. Number of days stayed is just the count of the stay dates. So again, we have a row of data for every individual date that person stayed. So that's all the number of days stayed. It's just counting the days for John. It was 3. And then number of nights stayed is simply a calculation, number of days minus 1. Now, you may look at this and go, what's up with this is blank thing? Well, if I didn't include that, this calculation actually does something kind of weird, and every date in between, even if like Tyrion didn't stay in January, it would have generated a calculation for it of blank, so I get all these extra nasty rows. This just filters that out, so that way my pivot table is nice and clean and I only get the numbers that I want. All right. So that one's the derived dates. All right, now the last one, this one's the fun one. This is what I call dimensional alchemy. And I see this all the time with people. My data source is one giant flat table. Everybody's always telling me, hey, Power BI wants a dimensional model. How do I do that? So here in this example, this is my actual original source. It's one giant table with a bunch of columns. I turned this into this. All right, kind of fancy, huh? Well, you may look at it and go, wow, that's super complicated. Why on earth would I do that when I could just have one giant table? Well, number one, scale. Dimensional models scale so much better than just one giant flat table, right? Because if I have one giant flat table, if I only have 1,000 rows, you could probably get away with it. Just having one giant flat table, where you can come in here and do a visual, and here's the one giant flat table. If I want, you know, I've got everything in one table, right? Makes it super easy. The problem is if I come here and do like age range and throw that down as a slicer, what's going to happen is, again, one giant flat table, and a slicer is a distinct list of values from a column. So if this table has 1,000 records, it has to go through 1,000 different records and then find a distinct list of values from 1,000. If that's 10 million records, I have to go parse through 10 million records to get the distinct values, and that's gonna be slow. All right. So dimensional models, the reason that we go with that is a dimensional model, like I just threw age range in there. An age range dimension is just all the distinct age ranges for you already. And look at this. I only have, you know, a handful. I have 11 rows, right? So if I want to use age range as a slicer, it's 11 rows of data, right? Now, here I've got my distinct values from the age range. And over here, I've got what we call a surrogate key. It's a numeric representation of this value. Now, in a well-modeled dimensional model, let's go to the fact table here, the overdose table. So this is the new fact table that I derived. You saw the old one. If I scroll over here to the right, my fact table has a bunch of key columns. These are all keys that are relations. So rather than me storing gender, the text of gender, male, 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 female, female, unknown, 1,000 times or 1,000,000 times, text tends to be much heavier in tabular models. So numerics is what you want. That's where the performance, that's where this thing really starts screaming when you have numbers, especially when we're talking about filtering data. So in my fact table, what I end up with is a bunch of numeric surrogate keys, and those are the relationships here. So now if I go to do slicing and filtering, like, hey, I want to slice by ages, I got my ages dimension, and that relationship is on this age range ID, which is a numeric field. So now I filter on 35 to 40-year-olds. That filter context gets applied to 11 rows, so that's one filter context that gets passed this way. And then this table, remember that the tabular model is a columnar database. So the way everything is stored in columnar is by column. So all my age range data is stored as columns, and it's as numeric, right? So I've got 1, 1, 2, 2, 2, 5, etc. Now in a columnar database, it's stored as also in segments. So we have these like little segments. So data stored this way, and this way. Now, when we're doing giant aggregations on stuff, the reason that the tabular model is so fast is because we're filtering on at the column level. If I select age range of 2 on my age table, that filter context gets passed here. The tabular model only reads the segments that contain 2. So I only need to read this segment and this segment. I don't need to read this one, and that's a performance benefit. So that's why if you're slicing and dicing and doing aggregations with a well-formed dimensional model, that right there is where your speed comes in, because the model's only reading the segments that it needs to, does the aggregations very fast, very efficiently. All right. So how I did this, again, a couple minutes here. Number one, I duplicated the query. So you can right click a query and do duplicate or reference. Duplicate actually duplicates the entire thing, including any and all steps that you've done here. This data set here is a public data set. It's scraping off a public API endpoint from data.gov. So I duplicated this guy to get me my overdose fact table. Now my overdose fact table, you can see, has a bunch of different transformations here. Now let's take a look at one of the dimensions first. So here's a simple one, the gender dimension. So these are all my distinct genders in my data set and the derived keys. So I went from this to this. And the way I did that is, number one, when you look at the data set up front, you look at the columns and you go, okay, what would make a good dimension? So I decided gender is going to be its own dimension. So I'm going to scroll over to gender, right click the column and do remove other columns. That's going to get me just the male or just the gender field. Now I've got all these distinct values, so I'm going to come here, remove rows, remove duplicates. That's going to get me my distincts. And then next is my surrogate key. I add a index column here to generate my surrogate key for me on the fly. So 1, 2, 3, boom. Now I build out all my dimensions first so I can get my keys generated for all my dimensions. Then I go back to my fact table. And here what I do is one at a time pick off what I want. So here I want to bring in the gender. So right now my fact table has gender, male, 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 female, repeated over and over again. What I'm going to do is I'm going to merge to my gender dimension. And again, that's done up here through merge queries. I'm going to explode this out to get me the gender key from that gender dimension. And then once I have my key column in here, then I can go back over here and then get rid of my gender field. So I go clean up my model a bit. This is going to make your model very, very efficient because now it's going to compress better because it's all kind of numerics on your fact table for the most part. And the performance is going to be much, much better. And this model will scale so much better. All right. All right, so that's it for dimensional alchemy. And again, we've covered a lot of stuff here. Thank you guys very much for joining me today. Again, all of these sample codes are uploaded to my GitHub repository. So github.com/SQL Chicken. It's under the code samples repository. If you guys have any additional questions, please, please, please join us over on the Facebook group. So search for a Global Power BI user group. If you're not already a member, we'd love to have you. Just answer the questions and we'll let you right in. All right. With that, thank you very much.